Assalamualaikum dan selamat sejahtera. Physics Form 4 EBelajau Wave 5.6 Interference of Wave. Okay, today we are going to continue our lesson Interference of Wave. So we continue with standard learning. First, relate lambda, A, X and D for the wave interference pattern. 4. Solve problems involving interference of wave. Third, communicate on the application of the interference of wave in daily life. Okay, so we continue with activity 3. We are going to discuss factors affecting the interference patterns. So this is the diagram to show you the interference pattern for water wave. Okay, so remember we have the antinode line and also node line. Remember, so this is A, the distance between two coherent sources or two dippers of the ripple tank. So we have the interference pattern depend on the value of X. So when X change, the interference pattern also change. Write equation in terms of X. So we have the formula lambda equals to AX over D. Remember, lambda is the wavelength, X is the distance between two successive antinode line, and D is the distance where you measure X and the two coherent sources. So we rearrange and we get the formula X is equal to lambda D over A. Now we have look at the first activity ataupun the first factors. Remember, so X depend on three factors: lambda, D and A. Right, so we are going to discuss the three factors. So we take the first one, A, the distance between the two coherent sources. So we are given two diagram, diagram A and diagram B. Okay, so this is A, S1, S2, the distance between the two dippers. So this is for diagram B, this is A, and this is a D, right? And here is the X. Okay, first question, compare the distance A. So distance A, seems that A is bigger than A. Diagram A is larger than diagram B. Okay, compare the distance X. So this is the X. So it seems that A is lower. So A is lower than B. State the relationship between A and X. So here we have A bigger, here is A lower. So this is what inversely proportional. So A is inversely proportional to X. State two other physical quantity that needs to be fixed to ensure the top relationship is correct. Remember, X is equal to lambda D over A. So A is inversely proportional. So we have D and lambda are fixed variable. Okay, draw a graph X against A. So inversely proportional. So this will. Okay, now we discuss the second factor, wavelength, lambda. So again, we are given two diagram, diagram B and diagram A. Okay. So first question, compare the wavelength lambda. So lambda A, this is lambda A from crest to the crest, crest to the crest. So B is bigger than A, right? Compare the frequency F. So B, lambda and F is inversely proportional. So B is smaller than A. Okay, frequency of B smaller than frequency of A. Then compare the distance X. So B has a larger distance X than A. Okay. Next, state the relationship between lambda dengan F. So lambda and F is inversely proportional. Then state the relationship between lambda and X. So lambda and X is directly proportional. State two other physical quantity that needs to be fixed. So we have D and A. Okay, D and A. And draw a graph X against lambda. So which is directly proportional. So X and lambda is directly proportional. Okay, next, the distance from two sources to the point of measurement of X, or D. So we have the formula X is equal to lambda B over A. So state relationship between D and X. So X and D are in the same line. So they are directly proportional. State two other physical quantity that needs to be fixed to ensure the top relationship is correct. So we have now here is lambda and A. Okay. Draw a graph. So directly proportional, X directly proportional to D. Okay, now this is the conclusion relationship. So lambda directly proportional to X. D is directly proportional to X, and A is inversely proportional to X. Okay. So remember this formula. Okay. Lambda and X on the same line. X and D also same line, so directly proportional. But X and A X upward, A bottom, so this is what inversely proportional. Okay, now we move on to the next one is interference of light. So we are going to show the interference pattern for light wave. So we have here is a laser pointer. This is a double slit. Double slit acts as the coherent sources for the light wave, and here is the screen. Okay, so let's.
Okay, so I'm going to try and demonstrate to you a practical experiment called Young's double slits. Each of those things that you can see there, oh no, that's lovely, that's focused really nicely. So you can see that each of those things that look like one slit is actually a pair of slits, because that's going to work best. So I'm going to shine this laser through a double slit, and then all the way over there, I'm not sure if you can see it, is a screen. It's a long way away, and I'm going to direct the laser through two of the slits. So the laser light is going through a double slit, two slits very close to each other. All the way down there on the screen you might just see some red. Now actually let me show you what it looks like without the double slit. Without the double slit it looks like a dot. Okay, let's go back. Now I've put a double slit in the way. So the laser light is passing through both of those slits, it's spreading out, it's diffracting, but when it gets over here, you get this very interesting pattern of bright and dark fringes. So it goes bright, then dark, then bright, then dark, then bright, then...
Okay, so that is the pattern that we can observe from the experiment. Okay, so this is the experiment that we can do. What we do is first we get the pattern just now, and then we calculate X. So what we have is a red is bright fringes, and dark alternately, and they are uniformly. Okay, so we can calculate X. Okay, first this is Y is distance from here to here, means that 9 minus 1.8, and then you have to divide by 4 because you have how many X here. So X, 1X, 2X, 3X, here is 4X. So what we have, 9 minus 1.8 divided by 4, this is 1.8 centimeter. Okay. Now the red light from the laser pen is monochromatic light. So what is meant by monochromatic light? So light with one color or with blank. So this is only red color, right? Okay. Describe the interference pattern observed while light passes through the double slit. So we have bright and dark line alternately and uniformly. Bright, dark, and alternately and uniformly, same distance. So this is for the smaller. I think it's smaller A, and here is a longer A. Now, this is the picture of my student doing the experiment in order to determine lambda of red light, okay, by using laser pointer. So before we calculate a lambda, we use this formula, lambda equals X over D. So lambda equivalent to the wavelength of the red light. A is the distance between the double slits. D is the distance between double slit and the screen. X is the distance between two successive bright fringes from one light to another light. Okay, so calculate wavelength of red light. So formula lambda equals to X over D. So X is 1.8 and lambda is AX over D. So 0.5. I have to convert millimeter to meter. 0.5 times 10 minus 3 times 1.8 convert to meter is 10 minus 3 divided by 2. So D is 2 meter. So 2 meter. Right, so we get the answer is 0.45 times 10 to minus 6 meter, or in standard form 4.5 times 10 to minus 7 meter. Okay. This is what we get from the experiment. So here we have the range of y, 1.4 cm. So it have 11 fringes, so equals to 10x equals to 1.4 cm, and divide, so we get 1.4 millimeter. So given that A is 0.5 millimeter, D is 1 meter, what is lambda? With X is 1.4 millimeter, and we calculate and we get the answer. So 0.5 times 10 minus 3 millimeter, convert to meter. 1.4 times 10 minus 3 millimeter to convert to millimeter to meter, and D is 1 meter. Okay, so the answer is 7.0 times 10 to minus 7 meter. Okay, the value is quite near to the actual value, about 6.5 meter, right? Okay, so next question, what will happen to the fringes on the screen when distance between the double slit and screen is decreased? Remember the formula. So what happened to the fringes on the screen is referred to x, right? What happened to x if distance between double slit A, then remember the formula, x to lambda d over A kan, remember? So double slit A inversely proportional, so it will be decreased. Okay? So when A distance between double slit and the screw, sorry, this is referred to D. So they are D and X is directly proportional, right? So this is will be decreased. Okay, so next, red light is replaced by blue. Red has the longest wavelength among the 7 spectrum. So blue is lower wavelength. So we have lambda directly proportional to X. So blue has a shorter wavelength, therefore it will be decreased. Okay, lambda red is larger than lambda blue, so it's blue. Now the last one is distance between double slit is increased. Double slit means A. So we discussed just now, X inversely proportional to A. So when A increase, therefore X will be decreased. Okay. This is the example where we use smaller distance for A. So we have not many fringes here because the distance is bigger here. But here we have a larger separation of slit. This is for X is smaller. When X smaller, so A is bigger here. So we use here is A is bigger. Okay, so we have a smaller fringes here. Okay, so X is smaller. Okay, now the next one we're going to learn about sound waves, to study interference of sound wave. So we have the audio generator. So this is audio generator connect to 2 loudspeakers, and here we will walk along in front of the loudspeaker along the straight line here. So the distance between the loudspeaker and our position is what we call D. So here is another picture here. So 2 loudspeakers is the 2 coherent sources, the audio signal generator which produce the sound wave, and what we walk along here. So we will observe loud sound and low sound alternately. Okay. Okay, next, the 2 loudspeaker and the sources of the 2 coherent sources. Why? Yeah, because both loudspeaker are connected to the same audio generator. Okay, so they have the same frequency. Where can you observe when the 2 loud sound overlap? Yeah, you can hear loud sound and soft sound alternately. So like this. Okay, explain your answer or explain your observation. So loud sound refer to constructive interference. Soft sound refer to disruptive interference. Last question, why the experiment must be done in an open area? Yeah, to avoid the reflection of sound wave or echo, right? Okay, so how to calculate lambda? By using the formula lambda is over D. So lambda is the value of the wavelength of the sound wave. A is the distance between the 2 loudspeakers. D is the distance between the loudspeaker and where X measure. And X is the distance between 2 successive loud sound. Okay. Alright, let's try to solve problem involving interference of wave. Okay, so now first question. Experiment on the interference of sound wave. Two loudspeakers are placed at a distance of 2 meters from each other. So this is A. The distance between the two consecutive loud sound is 1 meter. Oh sorry, this is D just now. This is A. And the listener is at the distance 3 meters from the loudspeaker. Okay. Silap. Okay, now two loudspeakers are placed at a distance of 2 meters from each other. So this is A. The distance between two consecutive loud sound is 1 meter. This is X, right? And the listener distance from the loudspeaker 3 meter. This is D. So use the formula lambda AX over D. So this is the same unit, so do not need to convert anything. So you get 0.67 meter. Okay, question 2. Experiment on the interference of water wave using a big water tank. The distance between two barometer 5 cm. So this is A, 5 cm. The distance from the barometer to the station where the antinodal line is observed is 50 cm. So this is D. The distance between consecutive antinodal line is 16 cm. Right? This is X. So lambda. So lambda is 5. So the same unit, right? cm. So we get 1.6 cm. Okay, now we have also again water wave. What is the wavelength? So what can we get from this picture diagram? So here is 4 cm is referred to A, this is referred to D, and here we have 16 cm, but we does not have what we have more than 1x. So this is 1x, 2x, 3x, 4x. So x should be 16 divided by 4 is 4 cm. Okay, so x 60 divided by 4 is 4 cm. So again, use the formula AX4 times 4 divided by 20 equals to 8.8 cm. Now we move on again to the sound wave. Two loudspeakers placed at the distance of 1.5 meter each other. So this is A. Connected audio generator frequency is 0.5 kilohertz. Remember, this is kilohertz. First question, the wavelength of the sound wave. Okay, what is the value of the wavelength when the speed of sound is 300 millimeter per second? So B is given, so V is given, F is given. You want to find lambda, so use the formula V equals to F lambda. So V equals to F lambda. So lambda equals to 300 divided by 0.5 times 1000 because of kilohertz. And the answer is 0.6 meter. Next, the distance between two consecutive soft sound. Okay, I think this is X, right? Distance 5 meter. So D is 5 meter, A 1.5, lambda is 0.6, right? So 0.6 times 5. Again, same unit, right? So no need to convert. So you have 2 meter. Okay. One more question, light wave. Yang double slit experiment is referred to light wave. Distance between double slit is 4 meter. This is A. Separation of the two slit is 0.5 millimeter. So this is A. Again, this is A. This is D. So calculate the distance. So this is X, and the lambda is given. Alright. So we use the formula X equals to lambda D over A, right? So 7 times 10 is lambda, 4 is the D, lambda D, and X is, A is 0.5 millimeter, convert to millimeter is 10 minus 3. So you convert, you get 0.0056 meter, so convert to millimeter, 5.6 millimeter. Okay, another question. So this is light wave. The separation of distance of the two slit is 0.25 millimeter. So A is 0.25, and then the distance to the slit. Okay, this is D. Calculate lambda. Now we have to find X from the diagram. So here we have 40 millimeter. How many X do you have here? So 1, 2, 3, 4, 5, 6, 7. So we have 7. So X should be 40 divided by 7. You get 2 millimeter. You convert to meter, 10 minus 3 meter. Use the formula lambda AX. So this is A, 0.25. 10 minus 3 times 2 times 10 minus 3 divided by 3. And you get the answer in standard form, 1.7 times 10 to minus 7 meter. Okay. So now we move on to the last part, application of interference of wave in daily life. So here we have what we call bulbous bow. This is the each big tanker should have this one. So generate water wave. So this will generate water wave which interfere destructively with the water around the whole hull. This one, So this cause the water around the ship to become calmer and will reduce the water drag. So it can move faster, right? Another one is the coating on the surface of anti-reflection lens cause reflected light to interfere destructively. This helps to improve the vision of viewer, right? Okay, so next, microphone. Transmitter system in headphones used on aeroplanes produce sound wave which interfere destructively with the surrounding noise. So it's very quiet. It will not interrupt the pilot in the cockpit. Okay. This also used for the workers at the airports. Okay, it's very noisy. The sound of the aeroplane is very noisy. So what it do is the microphone will emit its own wave, and it will interfere destructively with the noise, and it will have a zero amplitude, so it will be silent. So this will make the safe for the workers to work in the noisy area. Another one is the active noise control inside the cabin of an aircraft. If you have you able to go into the cabin of the aircraft, is very quiet with silence. This is because we have a system where the wave generated by the engine is cancelled, interfere destructively with the another wave which is produced by the loudspeaker, which have the same frequency, so 2 hertz also, but they are out of phase. So cancel each other by destructive interference, and no noise, no amplitude. So the inside the cabin is very silent. Okay. And lastly, maybe you can see this on the oil on the road. As you see, like colors. These are interference colors. And here is you can see on the disc, right? Because the disc you have a very small holes, right, inside on the disc. So this will provide interference to form the color like this. Okay, thank you for listening to my lesson today. I hope you understand. So thank you very much. Assalamualaikum and goodbye.